Right. The point M here is actually the center of the large circle, and the point on the small circle having center um, the origin O with 0, 0 coordinates. N has the coordinates minus 11 and P. A tangent is drawn to touch the large circle at T with NT is parallel to the y-axis, and M is a tangent to the smaller circle at M with MOS a diameter. Right, we've read the information given. We need to determine the equation of the small circle. So we're going to now solve question 4.1. Right, and to determine the equation of the small circle, we realize that it's centered at the origin, so the equation is x squared plus y squared is equal to r squared. And the conclusion, therefore, is that r squared is the same as what? Right, it's the same as the following. It's the same as minus 3 because you see the point M there. The point M has coordinates minus 3, 4. X, Y. Right, so x is minus 3, 4 squared. 9 plus 16, which is 25. And the conclusion, therefore, is that x squared plus y squared is 25. So now you have 4.2. Determine the equation of the circle centered at M in the form that M is the center of the larger circle there. Right, there are a couple of observations you need to make here. And one observation is that Tm is actually perpendicular to Tn. Right, you see that Tm here is perpendicular to Tn. The reason for that is that a tangent to a circle is perpendicular to a radius. Which means T will have coordinates x equals minus 11 because you have x, y there, x, y there. So the coordinates of T will therefore become minus 11 for x, and y will become 4 at the point T. Which means we have this one is minus 3 minus 11. In other words, the radius of the circle, therefore, can be obtained by saying minus 3 minus 11. Distance from there to there, positive. And therefore, this one is exactly 8 units. Right. With that said, it means, therefore, x plus 3 plus y minus 4 at the point M minus 3, 4. Minus 4. You square these. After squaring this, what we're getting is the radius is 8 squared. So this is exactly x plus 3. You square these plus y minus 4. And the result is 64. That is the case. And obviously, we note that we used a formula here. The formula we used is the x minus a squared plus y minus b squared is the radius squared. Okay, that is the formula we use. used there. Okay, we have that. Now we continue to do the next one. And to do the next one right now, we're going to be solving 4.3. Right, so to solve 4.3, we proceed as follows. Right, so 4.3, we note that we want to find the equation of NM. NM. So there's O. Okay, and then M has the coordinates minus 3, 4. As the diagram shows. From this, we can be able to find the gradient of the line OM. So the gradient of the line OM is actually y2 minus y1 divided by x2 minus x1. So this one is x1, y1. This one is x2, y2. So what is y2? It is 4 minus y1, 0 divided by x2 minus 3 minus x1, 0. So this is minus 4 over 3. So what do we obtain at the end of these? Right, from these we're able to obtain that we have the following. So we have found the equation, the gradient of OM. OM. So this means therefore the gradient of NM is exactly 3 over 4. Right. Because NM is a tangent, so it is tangent. The reason is tangent perpendicular to radius. With that said, we finish off the calculation here now. We finish the solution here at the bottom here. We remember that y minus y1 is m into x minus x1. Through the point M, you would have y minus 4, and the gradient is 3/4 into x minus into minus 3, which has the coordinates minus 3, 4. Right, upon further simplification of this, it's clear therefore that y is equal to 3 over 4x plus 25 over 4. 3 over 4x plus 25 out of 4. So that is the equation there. So in other words, we just finished off here 4.3. We just finished off here 4.3. Now we want to now do next, calculate the length of Sn. 4.4. We do 4.4 next. How do we do 4.4? Right, 4.4 can be done with ease. Right, so 4.4 can be done with ease here. Right, to do 4.4, we proceed as follows. Right, proceed as follows. Right, so we're gonna do 4.4 now. Right, so in doing 4.4, we first note that the point N has the coordinates minus 11 and P. Moreover, we note that the equation obtained just now is 3 over 4x, 3 over 4x plus 25 out of 4. Okay, now this here is basically the equation of, right, so this here becomes the equation of, the equation we obtained above, right, in 4.3, and that was the equation of NM. So this provides X and Y, and then Y is P. X is minus 11. We simplify this and we're able to see that P is negative 2. All right. Now, after having seen that P is negative 2, right, we're able to see therefore that this implies that the point N has coordinates minus 11 was minus 11 and P, so it's minus 11 and minus 2. Okay. Next, we find now the length that is required, but first we must find the coordinates of the point S. What are the coordinates of the point S? Well, we see that here is the origin is the midpoint of the line there. Right, so let's continue with this problem and solve it successfully. Right, so to solve this right now, we proceed as follows. Right, we're going to solve this question with ease. Finishing 4.4 solution. Finishing 4.4 solution. Okay. Now here, the coordinates. Right, want to first find the coordinates. The coordinates of the point S. If you shall say it's XS, YS. Or you call them XS, YS. You find the coordinates. So it's minus 3 over 2 is equal to 0 at the origin. And we have 4 plus YS over 2 equals 0. And the coordinates of S there, where the 0, 0 is the origin, And therefore, we're able to see that xs is the same as 3. Ys is the same as -4. So the coordinates will be 3 and -4. So which means therefore that Sn right now using the distance formula. So you can find the distance between S and N. Where S now will have the coordinates 3, 4, 3 and -4. And N will have -11 and P, which is -2. So we have Sn. Right, so the distance here would therefore be given by the formula x2 minus x1, you square this one, plus y2 minus y1, you square this. And the square root is there, and which means you have this. So now at this point, it's Sn, move from S to N. So you can call this one x1, y1, and you can call this one x2, y2. In which case you have x2, which is -11 minus x1, 3, y2 minus 2 minus y1, 4, and the square root of 2 units. And this is the same as 14, comma 14 units, approximately. So that means that we have approximately Sn equals 14, comma 14 units. So we have solved successfully question. We solved successfully question 4.4. Next, we continue. Right, we continue to do the next one, and we want to solve right now 4.5. If another 4.5, we're reading the question right now. So if another circle with center B having coordinates -2, 5, and radius K touches the circle centered at M, having the values of K correct to 1 decimal place. Okay, so we have this. We have this. Right, so we continue to do this one, 4.5. Right, to do 4.5, there are a couple of things you need to consider. Right, there are a couple of things you need to consider. 4.5, you can even try to squeeze it here. If another circle with center B, another circle with center B, and B has the coordinates -2, 5. If another circle with center B and radius K touches the circle centered at M, determine the values or value of K. Right. We look at these very, very carefully. So we ask the question, what would BM be, the distance between B and M. Okay, we can use the distance formula for that one, but it is the square root of 2 units. BM is the square root of 2 units. Okay, because B is this one and M has the coordinates -3, 4, and we can find the distance there. The radius centered at M can be obtained as follows. Right, so the radius of second centered at M, so in other words, the radius of circle M is, the radius of circle M is 8 units. We saw that one before, is 8 units. Right, the distance between here and there is just 8 units. Eight units. Right, so now we are taking the point B, whose coordinates are -2 and 5. And we're saying if another circle with the center point B and radius K touches the circle centered at M, determine the value of K. Right, so we look at the point B. The point B is a point that is having here at this point here, x is -3. We can find another one where x is -2. X is -2 and y is 5, so it's a little bit higher somewhere there. So the point B is somewhere here, -2, 5. Okay? All right, so we find the distance, K, can then be obtained from that. So if this is the point, then we're saying there's another circle with center B, and it actually, and it has radius K, but touches the circle center M. So since it is inside here, it can touch in a couple of ways. So it can actually touch this way. It can touch this way. So which means now if the radius of this one is K units, the radius is K units. Right, it's K units. And now we can even extend it here. Right, so you can extend it here. So we are saying BM is a square root of 2 units. But also we note that the rest of these here is 8 units. So which means that it follows therefore that K is actually a couple of variables. So you can say K is 8 plus the square root of 2 units, because you have the square root of 2 here and the 8 units there. Or, so now, and this one is approximately 9.41 units. Okay, is actually another possible value. Another possible value. So in other words, you can look at K now as also if you measure the distance from here to there. Right, from the center point B, so it is also K, that distance. It is the radius. So you can therefore say it is 8 minus the square root of 2, which is exactly the same as 6.59 units, which means K is 6,59 units, approximately. Right, so think of that very, very carefully. So there are two possible values of K, 8 plus the square root of 2, 8 minus the square root of 2. Okay. So thanks everybody, goodbye to you.